Hey guys, Coach John here. This is the first installation of a series of videos that's aimed to help you understand more about what's going on when you're sailing your boats and racing, and how you can use this knowledge to better your racing skills. So today we're going to be talking about Vector Addition. Okay. Basically, this applies to the different types of wind that we experience on the race course and what is actually going on physically, so we can best trim our sails and reach our maximum speed. So first we're going to talk about a couple of different types of wind. This first wind is called headwind. So this is like the kind of wind, if you're sailing or driving a car and you stick your hand out the window, it's all the seemingly wind that pushes against your hand. It's not wind, it's just you're moving through the air and it creates a headwind. So you can see, like in this picture, this boat is moving, if I describe it with this arrow, and then since it moves, all the little air particles that it passes through create this headwind effect. Okay, so that's the first type. And then the second type, the one that everyone thinks about normally, is the true wind. So this is, just the regular wind. It's blowing. You have to figure out which way it's coming from. I wouldn't recommend licking your finger and trying to figure out which side is colder, because that's going to not give you a very good estimate of the exact direction. In sailing, we have to pay attention to the variation of the wind within a couple of degrees. So there's 360 degrees. If you're off by a couple of degrees, you can be off in your race course. So knowing if it's on this side of your finger or that side of your finger is not a good idea. But some other really good ways to check out the way the wind is blowing are by looking at flags. You can see little tiny ripples or waves. Sometimes those will be good indicators. If you can see puffs, just watching the direction that a puff enters the race course is going to be a good indicator of figuring out a wind shift, if you know the wind is oscillating or persistently shifting. And then if you have a mooring field, the wind will cause moored boats to point directly into their wind, because the wind just drags on them and they're held fixed by their bow line, which is attached to the front of the boat, making them point into the wind. Be careful about using moored boats, because if there's any kind of current that can affect the angle that they swing or are moored. So, for example, we were in China this past summer and we were sailing on a run, and there were some huge containers that were moored right next to us, and their sterns were pointing into the wind, which was kind of odd, but it was because there was such heavy current. Alright, so now let's get into Vector Addition. We'll talk about how this affects sailing in a second, but this is Vector Addition. So in Vector Addition we have a vector. This is basically an arrow that describes an angle and a velocity. So you could say it's like 1 meter per second at 0 degrees, it's straight up, okay? Then you could have another vector, it's vector 2 here, or this one right here, and this one's a horizontal vector. So same thing, horizontal vector, 1 meter per second at 90 degrees, right? Because that's a quarter of the way around 360, 90. Okay, so we're describing two perpendicular vectors here. If we add them together, the way you do it is you move all the way down one vector, if you were to plot this on a chart, and then you move from the end point of the first vector and then move the direction of the next vector, and where you end up on a grid is your vector addition. So you can see that in this diagram. We move up here, then we move over, and the end result vector, the resultant vector, is this dotted line, and we name that vector 3. Okay, so here's some more quick examples of vector addition. So we have a long vector here and a short vector here going the opposite way. The resultant vector is just this short vector this way. So you can kind of just see, this is just examples of, we're not actually calculating anything, but this is just so you have an idea of what's going on. So, for example, a long vector here, another vector here. You can see the resultant vector is going to be a long but short, like low angle vector, okay? Because it's all pushing this way, and then it retracts some of the vertical component. Okay. So yeah, now the implications for sailboat racing. So we just talked about our headwind, true wind, and so these are going to be our additive vectors, and then our resultant vector is the apparent wind. So this is a close-hauled boat here. We know it's a close-hauled boat. We don't have to see the sails or anything. We know it's a port close-hauled boat just because we know the direction of the wind, so the true wind. So any way that a boat is pointing in relation to the true wind can give you all the information you need about where sails should be trimmed, what tack it's on. Yeah. So we have our true wind here, and then our headwind here. So this boat is moving, and we have a resultant apparent vector. You can see how this little vector, if you moved a little bit further to this way and down, it would create sort of this longer intermediate vector. So this is our apparent wind. So this is when you're at full speed sailing along, you're not sailing in true wind, you're sailing in apparent wind. That's a common misconception. Now, so as boat speed increases, we have this little chart here, your headwind will increase, and then your apparent wind shifts towards the bow of the boat. So if we think about our wind clock, as you get closer to the wind, as the bow of your boat gets closer to the true wind, you want to trim your sails in more and more and more, and then until you get on a close haul, and that's when you should be fully trimmed in. But what I'm saying is you shouldn't be trimmed in until you're at full speed and on a close hauled, okay? Because if you're fully trimmed in, you're assuming that your boat is at its maximum potential. But if you're accelerating, that means you're not at your true potential yet, and so that means you have your apparent wind is still a little bit aft of where it would be if you were at full speed. So that means you're still in a speed build mode. And in a speed build, you want to keep your sails eased a little bit, just so you're gaining power, and you don't want to be luffing at all. Definitely don't be luffing your jib or your main. You want to keep your boat flat. We're talking FJs here, so flat, powered up, maybe a little bit of lured heel and a windward flatten if you're doing a maneuver. But the idea here is you need to ease your sails whenever your boat slows down. So that could be doing a tack, that could be doing a turn, that could be just if you hit a big wave, anything. There's anything that slows your boat down, you need to be aware of that and realize that your apparent wind shifted back, so it means you're more on a reach than not more on a reach than a close haul, but you're a little closer down towards a reach, and you're not directly on maximum speed going upwind. So try that out while you're sailing. And another good instance when this occurs is if a puff hits, suddenly your true wind is disproportionate to your apparent wind, and that is also creating an apparent wind shift back. So that's why another reason why you want to ease your sails, both to keep the boat flat and also to accommodate the apparent wind shift back towards your stern. So good luck. Hopefully this helps, and I'll talk to you.